In this lesson, we'll be solving some questions on distance and displacement. So question number 1. A car travels 100 meters east and then 50 meters west. Find the distance and displacement. So solution. Let me draw our cardinal point. This is east, west, north and south. And then our Cartesian coordinates. This is plus x, this is minus x, this is plus y, and this is minus y. Alright. So a car travels 100 meters east. So east goes to the right direction. So this is 100 meters east, and then 50 meters west. So to the opposite direction, because west is this direction. So this is 50 meters west. And now said find the distance and the displacement. Now for distance is equal to the total distance traveled from point A to point B. So let me just write it as AB, or from the starting point to the ending point. So the total distance here is 100 plus 50. So the total distance is 100 plus 50, so which is equals to 150 meters. So this is the total distance covered by the car. And then what about the displacement? So the displacement, the car moves 100 meters east and then 50 meters west. So the displacement is that shortest distance from the start of the journey to where you ended. So how far you are from the starting point. So that shortest distance is this x here. So for us to find our x is going to be, now this 100 meters east is to the east direction, that is positive right hand side. So as you can see in this Cartesian coordinates, the right hand side here is positive, so we're going to write it as plus 100. Then the car travels 50 meters west, that is to the negative direction. Look at this Cartesian coordinates. This arrow points to the negative direction, and so it will have a negative value. So this is minus 50. So this is equal to 100 minus 50, which is equals to 50. And so this is 50 meters, and then the direction is west because this car is still moving towards west direction. Alright, it's going to the east direction and then turned back and started going towards the west. So this is 50 meters west. So this is going to be the answer to this particular question. So let's go to question number 2. A person walks 4 meters east and then 3 meters north. Determine the distance and displacement. So solution. But then let's first of all draw our cardinal points and Cartesian coordinates. So this is east, west, north and south. These are our cardinal points, and then our Cartesian coordinates. This is plus x, this is minus x, this is plus y, this is minus y. Okay, so a person walks 4 meters east. So east is to the right hand side, that is the right direction. So this is 4 meters, and then 3 meters north. See north here is pointing upwards. So from here now we draw an upward line to the north, and it's 3 meters. Alright, so 3 meters. Determine the distance and displacement. So let's assume that this is point A and this is point B. Okay, so the distance is the total paths taken while making the journey. So the distance here is equals to 4 plus 3, because that's the total distance. So distance is 4 meters plus 3 meters. So distance is equals to 7 meters. Alright, so let's find the displacement. So the displacement is given by the shortest possible distance from where you started the journey to where you ended the journey. And so here is that distance here. Oh no, this my line is not straight, but wait, okay, let me take it again. Yeah, this one is better. So from point A to B is our displacement. Let me name it x. So to find this displacement, we are going to use Pythagoras theorems, which states that hypotenuse square is equals to adjacent square plus opposite square. So hypotenuse is the longest side of the triangle, especially right angle triangle. So you have that x square is equal to, and that longest side is this x. So x square is equals to, adjacent square is the side that has both the reference angle, and then this is angle 90. So, and this adjacent is 4 square, that is this 4, and then the square here is in the definition. So plus opposite is this 3, that's the side that is facing the reference angle. So this is 3 square. So I have that x square is equals to 4 square is equals to 16 plus 3 square is equals to 9. So x square is equals to 16 plus 9 is 25. So let's find the square roots of both sides. So this and this will cancel. So I have that x is equals to square root of 25 is equals to 5. So the x is equals to 5 meters. So the displacement of this person here is 5 meters. So let's talk about the direction. So according to this cardinal point, this is east, west, north, and south. So if you draw this cardinal point here, you have that this is going to be east, this is going to be west, this is going to be north, and this is going to be south. So this side of displacement, this shortest side that is our displacement, lies between this north and east. So the direction is northeast. Alright, so question number 3. An athlete covers 3 rounds on a circular track of radius 50 meters. Calculate the total distance and displacement traveled by him. So let's take note of this circular track. So this is solution. So let me draw this track. This is a circular track. Alright, so I want you to understand this thing very well. So this is a circular track, and this question said that an athlete covered it 3 times, that is 3 rounds. Assuming the athlete started here, so it covered this the first time, alright, then the second time, and then the third time. He ended at his or her starting point. So we now say calculate the total distance and displacement traveled by him. Okay, so the total distance here, remember we are given that the radius of that circular track is 50 meters. So assuming this is the center of the track, the radius from here to this track is 50 meters. Alright, so here what we are going to find is the circumference of this circle. Alright, because it's a circular track, we are going to find the circumference of this circle. And so the formula for the circumference of a circle is given by 2 pi times radius. Alright, so this is equals to 2. We are going to use pi as 3.142. Okay, so this is 2 times 3.142 times our r, which is the radius, is 50. So then total distance is given by, just input this in your calculator, 2 times 3.142 times 50. So this is going to give us, this is equal to 314.2 meters. So this is the total distance traveled by this athlete. And then what about the displacement? So for displacement, the displacement is going to be equal to 0 because the athlete ended at the point he started, that is, he completed the journey. So that means that the starting point, it is end point, and so the displacement is equal to 0. It's just like an athlete ran 50 meters to the east and then ran back 50 meters again to the west. Remember, he started at this point and then he ended at this point. So if you calculate the displacement here, 50 minus 50 is equals to 0. So that is why if your ending point is where you started, then the displacement is equal to 0. Thank you for watching. Please subscribe to my YouTube channel and turn on the post notification bell so that each time I post a new video, you'll be the first to watch it.